Assalamualaikum everyone, I hope you guys are doing well. So first of all, Ramadan Mubarak to you all. I hope all your rosas are going fine. And in this video also has been a long time coming, and basically we are going to do past paper questions of combinations. So I've uploaded an entire playlist of permutations. I've covered an introduction of combinations. That's what we did in the last video. In this video, we're going to dive into some past paper questions, and we're going to dive into some very specific restrictions that we have to deal with. So overall, in this category, this is when combinations are applied to letters. So, you want to select of some letters from certain words, and then there are some restrictions that, you want to have at least 2 of so letters, or you want to have none of these letters. So stuff like that. So focus on the concept, don't just, your aim should not be to, just get the right answer. Sometimes, it could be a complete luck which will let you get the right answer, and you may not have absolutely no understanding of what the concept is. So make sure that you focus on the concept, and once you understand the concept, you can apply that to every question there is, and obviously get the right answer. So here is a question from past paper. So I'm going to solve like 5-6 past paper questions so that you can understand the concept, inshallah. So find the number of different selections of 4 letters from the 9 letters of the word happiness which contain no P's, either 1 or 2s. Okay, now if you look at the number of s that we have, so notice we have altogether 2 s's, okay? So a good idea is, when I'm solving questions like these, I always encourage students to write down the word before you start, okay? Now let's pause and think for the number of possible ways that we can do that. So we want to have no P's. So there's only one way to meet that condition, and that is you just got to have no P's at all. Then you got to have either 1s or 2s. So that means we could have 1s, or we could have 2s. So that means there are 2 possibilities with the help of which, or 2 possibilities that apply to this question. So one is that we have 1s. Okay, 1s. And remember, no P's. Now I'm going to copy this because I'm going to need it for the next possibility as well. So let's cross out the P's because we want to make sure that we don't end up selecting any of the P's. We want to have only 1s, so we can cross that out. And because we want to have only 1s, that means we cannot allow the other s to be selected, so we're going to cross that out as well. And do keep in mind, how many letters are we selecting? We're selecting 4 letters. So we're going to make 4 blanks for that. 1, 2, 3, and 4. Okay, now let's see how many letters we are left with. And bear in mind that we have already selected 1s. So if you count the number of letters that we are left with, that's 1, 2, 3, 4, 5. And all of them are unique, so we don't have to worry about repetition or anything of that sort. So that means we have 5 letters to choose from, and we have to choose 3. So that's 5C3, and you can work that out. I think that's 10, but to be on the safe side, let's work it out. So that's equal to 10. But is that it? Is that the end of the question? Obviously not. Remember that we said that we discussed that there could be 2 possibilities. The other possibility is that instead of selecting 1s, we select 2s. And the way to do that is that you first select the s's and then you see what's left. So I'm going to place 2 s's over here. Now remember, this is combination, so the order doesn't matter. As in, you can have the 2 s's here, you can have the 2s here, you can have one on this side, the other on that side. It really doesn't make a difference because order in combination is irrelevant. Now what are we left with? Remember, we cannot select P's. We've already selected 2 s's, so that means now we're down to, let's count, 1, 2, 3, 4, 5. Now we're again down to 5 letters, except this time we only have to select 2. So 5C2, which is also 10. So 5C3 is 10 and 5C2 is also 10. So that means altogether there are 20 ways where we can select 4 letters from the 9 which contain no P's and either 1 or 2s. Okay, so that was one, I would say, a relatively easy question. I'll tell you when things get complicated. Things get complicated when the letters that you have to select from are repeated. Like, for example, there is a question which I'm going to solve where you have 2 E's or 3 E's. So you'll see how we deal with those questions as well. Now, here's another question. Let's see what this says. How many different selections of the 4 letters, so here also we're selecting 4 letters, can be made from the letters of the word telephone if there are no E's? So as always, I would encourage you to write the word, and we have in the first part no E's. Okay, so this is actually part 2 of a certain past paper question. As you know, I have broken down permutation and combination questions into different categories. So this is not an entire question. These are just a few parts of a past paper question. So we got to have no E's. Now, how many ways can you have no E's? First of all, let's cross out the E's. And remember, how many letters are we selecting? We are selecting 4 letters. So let's make 4 blanks. 1, 2, 3, 4. So if we're selecting no E's, that means I've crossed out the 3 E's. And let's see what we're left with. We are now left with 1, 2, 3, 4, 5, 6. So that means now we're left with 6 letters and we have to select 4. So 6C4, let's work that out. 6C4, that's equal to 15. So 1 easy mark. Now let's do part 3, which is the second part of this question, but part 3 of the actual question. There is exactly 1 E. Okay, so there is exactly 1 E. Now, once again, I will encourage you to write down the word. So the word is telephone. And make 4 blanks to begin with. So this is the standard procedure. Now, we got to have only 1 E. That means we will cross out the 1 E that we have selected since we can't use that anymore. And we will also cross out the other E so that we don't end up selecting them again. Because if we end up selecting them again, we'll end up having more than 1 E. Now, what are we left with? We are left with, let's count the numbers we're left with. We're left with 1, 2, 3, 4, 5, 6. So we're down to 6 letters. And how many do we have to select? We have to select 3. So 6C3, which is equal to what? Which is equal to 20. So that means altogether, we can select 4 letters where there is exactly 1 E from the 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 letters, I think. 1, 2, 3, 4, 5. Okay, it's irrelevant, actually, how many letters in total, because we have to see what we're left with after we've fulfilled the condition. But yes, there are 9 letters. So 15 plus 20, that's equal to 35. So that means this can be done 35 ways. Okay, so I hope you're following. The procedure is that you first see what the condition is that's applied in the question, you fulfill that condition, and then you see what it is that you're left with and how many letters it is that you have to select. Okay, so we're going to solve some more questions to further get a good grip on this. Here's question number 3. Let's see what this is. This says, 4 letters from the letters of the word remembrance are chosen. Find the number of different selections which contain no M's, no R's, and at least 2 E's. Okay. So no M's, no R's. There are no 2 ways about it. But the question says at least 2 E's. Now, how many E's do we have altogether? We have 1, 2, 3 E's. So at least 2 means it could be 2 or it could be 3. It can't be more than 3 because we only have 3 E's to begin with. So that means there are 2 ways that we can do this question. Not as in like the answer is 2, but there are 2 ways. One is that we select 2 E's and the other is that we select 3 E's. So as always, start by writing down the word. Make sure you get the spelling right. Remembrance. You can just copy it. Here it is. Let me just double check. R-E-M-E-M-B-R-A-N-C-E. Okay, I've never been too good with spellings, to be honest. So let's start with 2 E's. Okay. Now I'm going to copy this so I can use it again. So it says 2 E's, but it also says no M's and no R's. So how many letters are we selecting? We're once again selecting 4 letters. So let's cross out the letters that we're not allowed to select. So that's R. Let's cross that out. And we're also not allowed to select any M. So let's cross that out. Okay. And since we're supposed to select 2 E's only, so let's cross out the 2 E's that we have selected. And let's cross out the other E since we're not supposed to select it. Because if we do select it again, then it becomes 3 E's. Now, what are we left with? If you count the number of letters that we're left with, so that's this one B here, A, N, C. So altogether, we're left with 4 letters, of which we're supposed to select 2. So that's 4C2. 4C2 is 12. 12 upon 2, that's 6. Okay, so this can be done 6 ways. Now, remember I said that you can also select 3 E's. The question said at least 2 E's, so that means you can also select 3 E's. Now, how can you select 3 E's? Let's have a look. So 1, 2, 3, 4. So we select the 3 E's. That means we write the 3 E's in the 3 spaces, anywhere in the 3 spaces, doesn't really matter. Let's cross out the letters that we're not supposed to select. So that's R and M. And since we have selected 3 E's, let's cross out the 3 E's as well. So 1, 2, 3. Now what are we left with? We're left with 1, 2, 3. We're left with 3 letters, of which we're supposed to select 1. So 3C1 is 3. No, wait a minute. We're left with 1, 2, 3, 4. We're left with 4 letters, sorry, not 3, we're left with 4. We didn't count the B earlier, so 4C1, which is equal to what? Which is equal to 4. So altogether, this can be done how many ways? This can be done 10 ways. Okay, so I hope you guys are following. Let's solve another question. It says, find the number of different selections of 4 letters. So consistently, we're selecting 4 letters, which is strange, which contain exactly 2 G's or exactly 3 G's. Okay, so exactly 2 G's or exactly 3 G's. Now this is a slightly complicated question, so make sure that you're paying attention. So first of all, let's write down the word. The word is aggregate. AGGREGATE. Okay, let's copy it because I don't know how many times we might have to use this. So let's start with the obvious one, and that is exactly 2 G's. So if I want to select exactly 2 G's, let's do that. Let's make 4 blanks. 1, 2, 3, 4. Okay, first let's select the G's. Now, since I've selected 2 G's and I want to have exactly 2 G's, that means we'll cross out the third one as well. Now, this is where you have to be a little careful. And what do I mean by that? Here's what I mean. If you count the number of letters that we're left with 1, 2, 3, 4, 5, 6. So that means, am I going to do 6C2? No, I'm not going to do 6C2. Why? Because yes, we're left with 6 letters, but how many unique letters are we left with? Let's count that. So we are left with A, R, E, and once again we have A, so we're not going to count that, and then T. So the number of unique letters that we're left with are basically A, R, E, T. So that means we are down to 4 letters, and of the 4, we have to select how many? We have to select 2. Now, why are we doing this? Why are we doing this? Why are we not taking all the letters at once? So for example, if let's say we have an A over here and a T over here, okay, so that's one possible selection. And if let's say I have this A over here and this T over here, so it's the same combination. So that is why, even though we have how many letters? We have 2 A's, but we're not going to consider them as 2 separate or 2 different objects because they're the same. They're 2 A's, so obviously they're the same. And the reason is very simple, because if you have this A here and this T here, that's one combination. And if you have this A here and this T here, that will be counted as another combination where actually it's the exact same thing. Okay, so 4C2, and what's that? 4C2 is 6. Okay, so that's equal to 6. Now let's see. Notice the question says that you can have 2 G's or exactly 3 G's. So let's see what happens if I have exactly 3 G's. So let's rewrite the word aggregate, and this time let's select 3 G's. Okay, so let's make 4 blanks. 1, 2, 3, and 4. So first thing you want to do is you want to select the 3 G's. Okay, so we've done that. Now, what can we have over here? Let's see. What we can have over here is, let's cross out the letters that we don't want to deal with anymore. So we don't want to deal with any of the G's anymore. Okay, how many letters are we left with? We're left with 1, 2, 3, and 4. So we're left with not 4 letters, but we're left with 4 unique letters, which means that of the 4, only 1 can be selected. So 4C1 is equals to 4. Now you might think that 10 is the answer, but it's actually not. This is where it gets interesting. Why is 10 not the answer, and why can I not just do this question the way that we have done other questions? Is for the following reason. So once again, let's go back to the word aggregate. Okay, and let's go back to the first, and actually, you know what? Let's make some room. I'll continue over here. So let me slide this to the left so we have enough room. Yeah. So let's go back to the word aggregate, okay? And let's go back to 2 G's. Now, one thing that we didn't consider, and it's worth paying attention to, is that what if after selecting 2 G's, the remaining 2 letters happen to be the same? What if after selecting 2 G's, the remaining 2 letters are the 2 E's that we're left with, or perhaps the 2 A's that we're left with? You know, what happens then? Is that not possible? Of course that's possible. So we have 2 G's and 2 A's. And when do we have to do this? We have to do this whenever there is a repetition. So after we fulfill the condition, the number of letters that we're left with, if there is some repetition in those letters, that's when we have to do this. Okay, I'll write a note for this as well. So 2 G's and 2 A's. And that's it. There's just one way to do this. There's no other way. So you don't have to, work out 5C2 or anything of that sort. 2 G's and 2 A's, that's it. And since this is combination, we don't have to select multiple, we don't have to consider multiple arrangements of this. Now there is another possibility. Another possibility is, so let's just duplicate this. Another possibility is that you select the 2 G's, okay, you select the 2 G's, and instead of selecting 2 A's, we've already done that, so we don't have to do that again, but the remaining 2 letters can both be 2 E's. Is that not possible? Think about it. Of course that's possible. So we have selected the 2 G's, so we cross out the third, so we don't end up selecting it again. And we select just like we selected the 2 A's over here. Here also we cross out the G's and we select the 2 E's for the remaining 2 places. Okay, and how many ways can you do this? Just the one way. Is there a third possibility? No, there isn't. I mean, you're very welcome to try, but you'll realize that there isn't. So this is equal to what? This is altogether 2 different ways that you can have 2 G's with the remaining 2 letters as A's and with the remaining 2 letters as E. So that means altogether, the final answer is going to be 10 plus 2, which is equal to 12. And there you go. That is the final answer. I'll write that over here. I'll squeeze this over here so that I can write an important note. Okay, so 12 is the final answer. Now, an important note. The note is that check for combinations where letters are repeated separately. Okay, so if let's say you fulfill the condition and the remaining letters are such that within those remaining letters there are some letters that are being repeated, so for those repetitions you check separately. Okay, so remember this simple note and you'll be fine, inshallah. So we'll come across questions like these again, and I should have said this sooner, but I would encourage you to now pause this video and solve this question yourself, and then you can play the video and see if you're getting the correct answer or not. So 4 of the 8 letters of the word Tanzania are selected at, it doesn't say at random, but are selected. How many possible selections contain exactly one N and exactly one A? So let's answer this part. Exactly one N and exactly one A. So start by writing down the word. So here it is. Now we have to select exactly one N and exactly one A. So first let's select the one N and the one A. So we make 4 blanks. Here we go. So we have one N and we have one A. So we cross out all the A's so that we don't end up selecting any more of the A's, and we cross out all the N's for the same reason. So what are we left with? We're down to 1, 2, 3, and of the 3 remaining letters we want 2. So 3C2 is equal to what? Is equal to 3. Is there any other way that we can select one N and one A? No, there isn't. It's just exactly one N and one A. So that's it. Now the next part. It's a 3-mark question, so I'm guessing that we'll need plenty of space to do the working. So this is exactly one N. So once again, let's write down the word. Here it is. So exactly one N. So what do? We make 1, 2, 3, 4. We make 4 blanks. Exactly one N means that we first write the one N. Now, I don't know how many possibilities we'll have to consider over here. We'll find out as we go along. So we cross out the N's. Okay, so we don't end up selecting any more of the N's. Now, here's the thing. After crossing out the N's, the letters that we're left with, are there any repetitions? Yes, there are. If you think about it, A is being repeated 3 times. Okay, so I hope you're thinking what I'm thinking, but if you're not, there's nothing to worry about. We'll figure it out together. So let's first count the number of unique letters that we're left with. So we're left with 1, 2, 3. Yeah, we're left with 3 unique letters. 1, 2, 3. No, actually, we're left with 4 unique letters. 1, 2, 3, 4. Yeah, so we're left with 4 unique letters. And that means we have to select 3 of them. So that's 4C3, which is equal to what? Which is equal to 4. Okay. Now, what is the one possibility that we did not consider? Here's a possibility that we did not consider. One possibility is that we have one N and we have 2 A's. Isn't that possible? What do you think? You think that's possible? Of course it's possible. How? Here's how. So we have one N and we have 2 A's. Okay. Now, if we cross out the N's, once again, here also I should have written the word separately. So let's do that. So here's the word. So let's cross out the N. Okay, and since we have selected two A's, that means we cannot select the third. So we're going to cross that out as well. So what are the letters that we're left with? We're left with 1, 2, 3, and 4. So once again, we are down to how many letters? We are down to, we are not down to 4. We're down to 3. Why? Because we've already selected N. We are only supposed to select one N, so we're not going to consider that. So that means we're left with 3. So that's 3C1, which is equal to what? Which is equal to 3. Okay. Now, is that it? Have we dealt with all the possible repetitions? No, we haven't. Why? Because one way that you can select 4 letters is that you have one N and you have 3 A's. Isn't that possible? Of course that's possible. There is no condition which says that you can't have 4 N's. You can't have 3 A's. So that's going to be N, A, A, A. That's it. Job done. So how many possibilities, how many ways can you do that? Just the one way. And now what we're going to do is we're going to find out the total by adding all these values. So we're going to add 3 plus 4, which is 7, 7 plus 3, which is equal to 10, and 10 plus 1, which is equal to what? Which is equal to 11. Let's see if that's the correct answer. No, wait. Okay, we weren't supposed to consider this 3. This is from the last question. Okay, so the answer is 4 plus 3, 7, 7 plus 1, which is equal to 8. So the final answer is, in fact, 8. So I'll give you guys a recap of this question because I know it's complicated. So basically, here's the word, and we're supposed to select 4 letters, and the condition is that we can have exactly one N. So here, the way that we have done is that we have one N and the remaining 3 letters are all different. That is possible because after selecting one N, we are down to 1, 2, 3, 4. 4 unique letters, so we can have the remaining 3 letters as all different. So that's one way. The other is that we have one N and 2 A's. Now, why are we considering this to begin with? Because in this word, we have 1, 2, 3. We have 3 A's. That means you could have a combination where you have one N and 2 A's. You could have a combination where you have one N and 3 A's. So we have to deal with them separately. So repetitions are such that you always have to deal with them separately. So we see what happens if we have one N and 2 A's. That means we still have to select a 4th letter. So after crossing out all the A's and after crossing out all the N's, we were down to 3 unique letters. So we have to select one, so that's 3C1. And then when we select one N and 3 S, so we've selected all 4 letters, and there's just one way to do that, and we add them up. That's the final answer. All right, so here's the next question. Let's see what this says. 4 letters are selected from the 10 letters of the word Copenhagen. Find the number of different selections if the 4 letters just contain the same number of E's and N's with at least one of each. So that means you can't have a combination, you can't have a selection where you have no E's and no N's, because you got to have at least one of each. All right, so once again, we're selecting 4 letters. Let's write down the word. That's the standard procedure. Copenhagen. Okay, so we got to have the same number of E's and the same number of N's. So an obvious way to start is to make sure that we select one of each. We select one E and we select one N. Now, I would like to copy this so I can use it again and again. So one N and one E. Let's make 4 blanks. 1, 2, 3, 4. In fact, let's copy this because we need the blanks as well. So let's cross out the letters that we have selected. So we've selected one E and we want to make sure that we have just one E. So we'll cross out the other E as well. Then let's cross out one N and we want to cross out the other N as well because we want to make sure that we just have one N. Now, how many unique letters are we left with? Remember, we have to count the unique letters. So 1, 2, 3, 4, 5, 6. All the 6 letters are unique. And remember, since we have selected one E and one N, so we are now down to just 2 spaces left and we have 6 letters to choose from. So 6C2, which is 30, 30.2, that's 15. Okay, now, what if we select 2 E's, and if we select 2 E's, that means we got to select 2 N's also because the number of E's and N's must be the same. So if I select 2 E's, I got to select 2 N's also. 2 E's and 2 N's. So 2 E's and 2 N's. That's it. There's just one way to do that. Nothing else to worry about. 5 marks, that's a little too good to be true. So 15 plus 1 is equals to 16. And there you go. I wouldn't say 5 easy marks, but not very difficult either. Now, I guess this is the last question. Let's see what this says. 5 of the 11 letters in the word requirement are selected. How many possible combinations, how many possible selections contain at least 2 E's and at least 1 R? Okay, at least 2 E's and at least 1 R. Let's write down the word and now we're selecting 5 letters. Okay, so not 4 anymore. Requirement. Okay, let's REQUIREMENT. Okay, so at least 2 E's and at least 1 R. So let's start with the obvious, which is that you have 2 E's and you have 1 R. And how many letters are we selecting? We're selecting 5. So let's make 5 blanks. 1, 2, 3, 4, 5. Now let's copy this because we might need this again and again. Now first let's cross out the 2 E's. Okay, and we want to select the third. We want to cross out the third E because we want to make sure that we just select 2 E's and 1 R. So let's cross out the R that we have selected, and let's cross out the other R also so that we don't end up selecting it again. Now what are we left with? We are left with 1, 2, 3, 4, 5, 6. Let's make sure of that. QUIMNT. So they're all unique. Okay, and we have to select how many? We have to select 2. So 62, which is equal to what? Which is equal to 15. Okay, now we've selected 2 E's and at least 1 R. Both are at least, that means we can increase them as much as possible. Now let's change the E's from 2 to 3. Is that possible? Yes, that's possible because we have 3 E's. So 3 E's are selected, so we can cross out the E's, and 1 R is selected, so we can cross out the 2 R's, not because they're both selected, because 1 is selected and we want to make sure that we just select 1. Now, how many letters are we down with? We are down to 1, 2, 3, 4, 5, 6. So 6 again, that's 6C1, which is equal to what? Which is equal to 6. Now notice that we have increased the number of E's, but not the number of R's. So let's increase the number of R's. So now I can select 3 E's and 2 R's. Is that possible? Requirement. Yeah, that's possible. So if I select 3 E's and 2 R's, so that's it. 3 E's and 2 R's. Yeah, so we don't have to worry about, so no letter is left, everything's selected. So that's one way to do that. Is there any other possibility? So we have done 2 E's, 1 R. 2 E's, 2 R's. I think we didn't do that. Yeah, we didn't do that. 2 E's and 2 R's. That's also possible because we have 3 E's in total and 2 R's in total. So of course we can do 2 E's and 2 R's. So 2 E's. So we cross out the E's, and 2 R's. So we cross out the R's. Now what are we left with? We're left with 1, 2, 3, 4, 5, 6. So we're left with 6 letters and we have to select only 1. So that's 61. Now let's add them up. Let's see what do we get. 15 plus 6 is 21. 21 plus 1 is 22. 22 plus 6 is 28. So 28 hopefully is the correct answer. And that's it. We have solved this question, and that also brings me to the end of this video. So I hope you've understood the concept. If you think about it, the concept is pretty straightforward. It's just that you have to keep your eyes and ears open. So yeah, that's it for this one. In the next video, we'll be dealing with different category of combinations. So I'll see you guys then. Until then, take care. Allah Hafiz.